So at the end of the last presentation, there were some good questions about lift and shift of applications and state. And so I'm going to be talking a little bit about a different mechanism for running code at the edge of the network. Zach's talk, I thought, was really cool. I love the workers concept and the fact that applications can start and complete very quickly in one process is wonderful. But some of the questions from the back in the earlier talk really illustrate why there are other models that also make sense. And I'm going to talk about application lifecycle management, following up on the talk at the panel, and about application modernization. And just to kind of close on that last point about stateless versus stateful, not every application can run stateless and in JavaScript or Ruby on that kind of infrastructure. So I'm talking about the other kind of application where you might run it in a container. We start out and we've maybe got a monolithic application that was built over some time. And we want to containerize it, modernize it. And so let me walk us through that journey. First, you're familiar with microservices and containerization, I hope. Show of hands. I mean, is this familiar? Fairly familiar topic. Containerization, running software in containers like Docker, really improves portability of those applications. I can run them on any of those boxes that you saw in Zach's presentation, running Linux, running Windows, what have you. So the first step in your modernization journey, you're architecting for microservices running as a set of containers that invoke each other as services. Then move on to continuous integration and continuous deployment to get that code built, deployed, operated. And then where do you run it? If you want to run in many locations, a popular way of doing that these days is using the Kubernetes platform to run your service in a stack of machines. Kubernetes, very briefly, lets you specify how your code should run, how and where. You package it into containers. Those containers run in pods on nodes. And Kubernetes takes care of scheduling the application across the nodes and rescheduling in case of failure, in case of the need for more instances, so horizontally auto-scaling. So Kubernetes is taking care of this for you, but you will need a Kubernetes cluster, Kubernetes infrastructure in order to be able to do that. There's cluster customization that you wind up doing, and application lifecycle management, which is the focus of my talk today. So some of these are fairly solved problems from an automation standpoint, but we perceive an automation gap as we're talking to customers and prospects in the market regarding customization of your Kubernetes environment and the application lifecycle management. So what do we mean by that? Containerizing your application is really a journey from Kubernetes bring up and your container networking interface. You've got to have some way for containers to speak to each other. I'm not going to talk through every point on here. I want to leave a little more time for questions and discussions at the end because I thought that was very valuable in the last one. But you see there's a set of things that we do that are, broadly speaking, Kubernetes customizations in the tan here, and then application lifecycle management. And I'm going to call out a couple of these in the next slide, but at the very far right, I do want to call out data distribution and synchronization, and that again ties back with where Zach was going. They're building at Cloudflare a platform, as I understood from the talk. I don't have independent information about this, but a data platform. So you who might need access to persistent data have some way to access it. Okay, so we at Rafay are similarly building a distributed key value store. This is a great way to hold data that you may need to share among instances. Some of that discussion in the previous session was about if I have multiple services that interact and they can find each other in the same process, that's super cool. What if they need to actually share data? Again, that's where state is pulled in. And it's really critical to have some way, some rational way to access that distributed state. So you can now, with containers, create a Postgres database as a container, run it in a cluster alongside the other services that are all part of your application. But you still need that ability to provide the data synchronization with Homebase. So, application lifecycle management. Let's really drill down on that. What are the things that we need to do? First of all, abstracting away the application, a prescriptive framework, what we call a prescriptive framework here, makes it easier, to design and manage the lifecycle for your containerized app, from deployment to ongoing operations and updates. Ongoing updates, think about you have a configuration change that you need to make. So that configuration specifies how your application should run. Every instance across however many clusters you have will need to get that same update. So lifecycle management includes the ability to update configurations, containers, as you have software patches for security vulnerabilities, say, you'll need to get new versions of software out as containers to wherever they happen to be running at the time. So where do they run? They run in clusters, and we found it helpful to think in terms of cluster blueprinting, leveraging the same term that Akreno is using for applications. But now with clusters, there are a set of capabilities that your application depends on. You may depend upon a service mesh layer, a data layer, something to load balance the requests as they come in. Debugging and tracing information, properties of service mesh can help operationalize clusters. So when you need to initialize a new cluster, this blueprinting can help ensure reliable operation, putting the same cluster configuration on top of each new cluster as it comes up, and reprinting as your blueprint may change. So the blueprint, think of it as a way to apply a change to clusters, new as well as existing. The more fun stuff for me on our path towards edge computing is the multi-cluster federation. Now, if it's just one cluster, there are a number of organizations who have built clusters and operate them, and that's fine. But when you're having to distribute code across multiple clusters, especially under multiple providers, multiple ISPs or managed Kubernetes services, the container and metadata distribution varies. So those pipelines, so a pipeline is essential to make it easy to deploy and operate your containerized applications in many, especially many disparate clusters. So this is one of the things that we've developed as part of our platform to operate the clusters across locations. Multiple locations, since this is the Edge Cloud session, I do want to spend a few minutes on that. The multiple locations is really important in order to achieve better end user performance. As you're looking to optimize application performance, putting the containers that interact frequently with your end user or with a device really helps improve performance. Other cases are if the device happens to be capturing image or video data. dropping that in a local instance helps improve the reactivity to that end device, which likely doesn't have the capabilities to do a lot of heavy lifting and processing. If you have tens of thousands or millions of these devices, you can't put a lot of compute on them. You won't put TPUs inside most of your, most cameras, consumer-grade cameras certainly. So multiple locations running compute stacks is vital for performance and scaling of large-scale applications. Finally, enterprise integrations. You want to easily integrate with critical productivity technologies like secret management and that runtime configuration updates, log and metric aggregation. So during the operation of your application, you're collecting metrics. You need to be able to see and control what's happening with your application as it goes. Some of the advantages of the platform that we've built, we're abstracting away the Kubernetes layer as much as possible. We find there's a serious skills shortage in the marketplace of Kubernetes versant development and operations teams. So the more we can do to help there, the better. In the ideal world, as a developer or a development team, you've containerized an application, identified the containers that run best at the edge, and then deliver them onto a platform and that provides this abstraction layer. Now the distribution and placement of those applications is taken care of for you, rather than having to write the underlying YAML, which stands for yet another markup language. This is an infrastructure as code paradigm for describing how an application should work. So we'll create the appropriate YAML for the cluster in which a piece of code is being deployed, and provide a central configuration management so you can control through intent-based placement where and when applications are distributed and run. So you might have a follow-the-sun model, potentially, where you want your application to be running during banking hours, and when it's not banking hours, save me the money. Don't run as many instances of my application. That's an example of when. On the where side, if you have GDPR or other compliance regulations, you need to express that intent in order for the code to be distributed to the places where it must run based upon your user population. If you have a user population coming from the EU, the GDPR applies there, and those user requests must be able to find sufficient compute resource in that geography at that time. Similarly, in Russia, Japan, elsewhere, you have these requirements. So intent, expressing intent, translates then into distribution and placement. So application distribution, we say one-click operationalization to any number of clusters. We're seeing a couple of different models in the world as well. We started out with an edge focus, edge compute focus, running clusters and deploying latency-sensitive applications. But as I was expressing to Zach before the session, we find that some of the people we're talking to say, couldn't I just do that with Amazon? And there's a lot you can do with Amazon, but only in a dozen or so large locations. Okay, so we've got locations in Packet.net and several other providers. Couldn't I just deploy my code to, why not just deploy my code to there? Well, there are a lot of aspects to lifecycle management, including the updates and so on, that make that difficult. And if not every location is large enough to support all of the containers you have, what goes where, when? That's a key part of that distribution piece. Finally, the service that we've built is a multi-tenant environment, distributed or operated as software as a service-based automation. This automates DevOps or SRE tasks so you can focus on critical deliverables that you have. There's one more thing I wanted to say. Let me go back to multi-tenant. So again, in the marketplace, we find there's some interest for deploying edge clusters, but the example I gave, couldn't I just do this or that? We find those kind of questions coming most often when organizations haven't tried to distribute in the large. When they do, think large auction companies or Zach's company, et cetera, when they do, they work through the challenges of application lifecycle management, of cluster management, and solve a lot of hard problems. I worked at Akamai for 16 years, and we solved a lot of hard problems in doing that. We built a lot of bespoke operational software that did the deployment, the monitoring, and the NOC controls. And we did it because we had to. What we're finding now is the people who understand the challenges have often built that to some degree, and as such, they're already using cluster technology, likely Kubernetes. Everyone's converging onto Kubernetes from Docker Swarm and Mesos and so on. This is the winning platform. And so they tell us we've got a platform. We've got clusters. I don't need your clusters. So we've actually morphed since our early focus on multi-tenant and really adopting more of a, bring your own cluster model. Bring your own cluster, and we can help with the operationalization of the code, of the infrastructure code. That's the Kubernetes updates, operating system updates, all the way up to your application software. We believe this will really help support distributed application development and deployment. Okay. With that, let me stop and take questions. Thank you.
During the presentation, you mentioned about RDBMS databases, synchronizing between sites. You guys are not involved on those, right?
That's correct. That's a huge challenge, RDBMS and transactional database distribution. There are companies that do that well, and we recommend to leverage that. The database that I mentioned, take the context of an e-commerce application where you have a product catalog of fairly static information. You have application logic. You have browse, cart, and buy transactions. The browse needs data, and a database may be helpful for representing that inside a given cluster. The cart operation, there is a persistent state. For that, you can store it in the cluster, but what if a user moves and moves from site to site and is now closer to a different cluster, or goes from work to home? You don't want them to lose the cart. So there, backing that in a distributed key value store, we see as having high value. And so we'll provide key value capabilities to support that use case. Where the in-cluster database is really for the SQL model and the value that provides, as opposed to storing user transactional state. And then finally, the buy transaction, in my view, for the next coming years, that will be off of the edge platform and run in back office type data centers where you've got the highly reliable, ACID durability database. So yes, hope that helped.
Any other questions? Awesome, thank you.
Thank you.